warahmatullahi wabarakatuh. My name is Muhammad Zuhairi bin Azman with matrix number DN180061. So our group will present about the production of ammonia through Haber process using iron with potassium hydroxide as catalyst. What is ammonia? Ammonia is a pungent colorless gaseous alkaline compound of nitrogen and hydrogen that is very soluble in water and can easily be condensed to a liquid by cold and pressure. Ammonia is one of the most commonly produced in industrial chemicals in United States. In the modern process, production of ammonia is by using Haber process. Haber process combine nitrogen from the air with hydrogen derived mainly from natural gas into ammonia. The reaction is reversible and the production of ammonia is exothermic. The equation represent Haber process is here, which is the condition is depend on the plant. There are a few processes to produce ammonia, starting with a natural gas feedstock, such as in the picture. A hydrogenation process will occur to convert sulfur compound to hydrogen sulfide. The gases will absorb and remove to convert into solid zinc sulfide. Then catalytic shift conversion is used to convert CO to CO2. Lastly, the catalytic methanation is used to remove residual amount of CO or CO2 from hydrogen. So, in the production of ammonia, there is hydrogenation process that I mentioned, where hydrogenation refers to the application of molecular hydrogen substance which add pairs of hydrogen atom to compound. Usually, hydrogenation require a catalytic for the reaction to take place under normal temperature and pressure condition.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And hi, my name is Muhammad Faris bin Abdul Hadi, matrix number DN180068. So today I present about type of catalyst, which is heterogeneous, properties of catalyst which is porous, and classification of catalyst that used in the reactor. For the title that we choose, which is production of ammonia by Haber process using an iron as a catalyst. So iron catalyst is selected that will be used in the industrial process, which is ammonia synthesis. Catalyst can be divided into two types, which is heterogeneous and homogeneous. So this iron catalyst is an heterogeneous reaction. The catalyst is in different phase from the reactor. So heterogeneous is a mixture of containing a solid and liquid consists of two phases. The mixture, whereas chemical in single solution, consists only one phase. For the homogeneous, so as we know, heterogeneous involves more than two phases, more than one phases. Usually, catalyst is a solid, which is iron, and the reactant in gases. So the product is also in the gases. This becomes a simple and complete separation of fluid product mixture from the solid catalyst. Why catalyst is used? Catalyst provide an alternative pathway with a lower activation energy and increase the reaction rate. What is reaction that happen in the reactor? First is nitrogen plus hydrogen and become ammonia with exothermic reaction. What will happen once the catalyst is used? The nitrogen have a strong triple bond that need to be break down. So iron base is the catalyst to speed up the breaking of the bond. So the condition of iron during the reaction is the temperature is 450 degrees Celsius and the pressure is 200 atmosphere or atm. Okay, secondly, for the part of properties of catalyst. Iron catalyst is porous catalyst. Many chemicals and biomedical reactions that take place within porous catalyst particle. Most of this process has been appreciable heat of reaction. As a result, the interaction between the heat conduction, diffusion of reactant, and chemical reaction have important role in the performance of the catalyst. So these three these three components can be affect the presence of the catalyst. In a large pore catalyst with a pore diameter above 50 nm, the transport of heat and chemical by convection, in addition to fusion, beside the catalyst need to be considered. Such big pore solid are used, for example, in hydrogenation reaction, in reactors, in production of ammonia in Haber process. Okay, that's for the porous catalyst. Okay, next is the general properties of ion. Okay, for the ion, for chemical and physical properties, ion is in group 8, which is the symbol of Fe. Ion atomic number is 26. Atomic mass is 55.85 gram per mole. State at 20 degrees Celsius is solid. The melting point is 1536 degrees Celsius. Boiling point is 2861 degrees Celsius. The density is 7.8 gram per centimeter cube. The reactivity with water, it react with very hot water and steam to produce hydrogen gas. So for the oxidation, this ion readily combine with oxygen in the moist air, which produce iron oxide, also known as rust. So the solubility is dissolved in acids. Okay, for the classification of catalysts that are used in the reactor, so the classification is the hydrogenation. Hydrogenation is meaning to treat with hydrogen. It's a chemical reaction between molecular hydrogen and another compound or element, which is nitrogen, by using the presence of the catalyst such as nickel, palladium, platinum. For the reaction, iron is used as the catalyst. The process is commonly employed to reduce and saturate organic compound. Hydrogenation typically constitutes the addition of pairs of hydrogen atoms to a molecule, often the alkene. Catalysts are required for the reaction to be usable. Hydrogenation reduces double and triple bond. So in this is triple bond in hydrocarbon, which is nitrogen. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nuraini Ganan, with metric numbers AN18026. Okay, now I will continue the presentation with the mechanism reaction for the Haber process. For the ammonia synthesis, the mechanism used for it is 7 steps. Okay, for the first step, as we know, for the Haber process to work, it requires 2 reactants, which is hydrogen and nitrogen. Okay, to produce the hydrogen, the methane will react with the water vapor through the steaming process in the primary reformer. The reaction will produce carbon monoxide and hydrogen. Okay, for the second step, the methane react in the primary reformer will only react partially. So the remaining methane gas will react with the oxygen in the secondary reformer. Okay, the secondary reformer is supplied with the air as the oxygen source. In this reformer also, the required nitrogen is added into the gas mixture. Third step, the carbon monoxide that produced in the primary reformer will oxidize to carbon dioxide, which is called CO conversion or water gas shift reaction. For the fourth step, the carbon monoxide and carbon dioxide will form carbamate, which is will clog the pipeline as a solid. So to remove both of the gas, we will use the gas scrubbing with 3-ethanol amine. For the fifth step, the gas mixture will compress to the operating pressure by the turbo compressor. Sixth step, which is where the actual production of ammonia take place, is the in this ammonia reactor. Okay, in this process, there are few synthesis parameters that need to be considered. Okay, for the first is proportion of nitrogen and hydrogen. Okay, the proportion of hydrogen determined is in the ratio 1:3, which is 1 volume of nitrogen to 3 volume of hydrogen. Okay, for the temperature, the lower the temperature, the slower the reaction will be. However, according to the catalyst principle, the lower temperature will counteract as the system will shift to the right by producing more heat. Thus, 400 to 450 degrees Celsius is the compromised temperature for the to produce higher yield amount of ammonia. For the pressure pipe, according to the catalyst principle, the lower the pressure, the fewer molecules will be produced. So, in order to increase the production of ammonia, the pressure need to be increased as high as possible. 200 atm is the compromised pressure that can be used in this process.
Okay, for the last step, this is where the ammonia is collected. Okay, the gas mixture will be cooled down first before the ammonia is removed. Ammonia will be condensed and will be easily liquefied if the temperature and the pressure is low enough for the ammonia to turn into the liquid form.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mumin bin Abu Zainuddin. My metric number is AN180056. Today I will talk about the hydrogenation. Hydrogenation are the chemical reaction between molecular hydrogen and other compound and element. Hydrogenation is applied in many applications, including in the food, petrochemical and pharmaceutical industry. Hydrogenation applies to the handling of substance H2, which is hydrogen combining material generally unsaturated with pair of hydrogen atom. This usually allows a catalyst to be used in the reaction under standard temperature and pressure condition. Hydrogenation is an exothermic reaction. A catalyst is requiring hydrogenation in order to produce a successful reaction rate. The reaction takes place at the extremely high temperature without a catalyst. An alternative path which the reduced activation energy is provided by a metal catalyst. This allows for a lower temperature reaction. Heterogeneous catalysts act as the important thing to the hydrogenation in the industrial process. In the processing of vegetable oil, hydrogen is also important because most vegetable oil come from the polysaturated fatty acid. The majority, but not all of the carbon-carbon double bond are minimized by the partial hydrogenation, allowing them suitable for selling and uses. Next, I will talk about the industry that perform hydrogenation process. First, petrochemical industry. Hydrogenation is used to convert alkenes into alkanes, paraffin, and the cycloalkene. Food industry, hydrogen is added to oil in a process called hydrogenation to make them more solid or spreadable. Next, vitamin and fine chemical industry. Hydrogenation applied to the reaction of organic compound and belongs to the most important transformation. So I will talk the advantage and disadvantage of hydrogenation. First, fast hydrogenation is the mechanism of raising the amount of dual bond in the molecule to transform unsaturated fatty vegan oil into saturated fatty acid. Some of the benefit of fat hydrogenation is longer shelf period for saturated fatty acid. The hydrogenation cycle also has the benefit of the higher melting temperature of saturated fatty acid due to removal of double bond. Next, the product is more stable because the rate of oxidation has been decreased, and furthermore, the texture of the product can be controlled out. And one of the disadvantages are hydrogenation sometimes generates trans double bond, which is trans fat, and this trans fat are affected by different health effects.
Assalamualaikum. My name is Nur Atira binti Abu Hashim and my matrix number is AN108103. So right now I'm going to talk about the sustainability development of ammonia in Haber-Bosch process. So first, energy. Energy consumption for ammonia production using SMR varies from 7.8 to 10.5 megawatt hour per ton of ammonia, including feedstock, which accounts for 80% of energy. Then ammonia is also within liquid state below -33 degrees Celsius or under 15 bar at ambient temperature and has an energy density of 4.25 kilowatt hour per liter. Next, we will move to the cost of Haber process, where the equipment design is very expensive due to the pressure need in this process. And others than that, pipeline transportation of ammonia is low in cost because this is around only $3.34 per ton per 1,000 million or $0.004 kilowatt hour for 750 miles compares to the hydrogen transportation, where the hydrogen transportation is very expensive. Next, the cost of production can be cut down. This is due because this Haber-Bosch process is a reversible process as it can recycle or reuse back the waste product, and automatically it can cut down the cost of the feedstock. And lastly, for Haber-Bosch process is for environment, economy and community. So first, Haber process is environmentally friendly, and also the emission of CO2 to the surrounding is decreasing because the CO2 waste are being sold to soft drinks industry. Then the usage of ammonia is around 85%, which produce fertilizer, which will increases the food supply to the community. Then, the excessive use of fertilizers can cause pollution. This is because when the fertilizer is used, then the nitrogen that contained in the fertilizer will absorb into the soil, which will flow to the river or oceans, which make eutrophication occurs. For catalyst, the catalyst did not react with the reaction in this process. And also, iron catalyst is being used in this process and with the addition of small amount of aluminium. This is because it can make the rate of reaction even more effective. Then the iron catalyst is most effective catalyst where compared to other transition metal species that has been tested in the Haber process in the making of ammonia. Then iron catalyst is low cost, and also iron is easy to obtain, where iron is one of the most transitional metal that can be found on the Earth's surface.